Hello everyone, welcome to ACE Maths. In this video, we are solving the IGCSE Extended Maths paper from May-June 2024, step by step, with full working and clear explanations. Grab your pen and paper and let's get started. First question now. Write the number 2,002,002 in figures. To solve this question, we need to first understand what does this sentence means. 2 million, we know that if I put 6 zeros after 2, that will give me 2 million, right? Then we have 2000, right? 2000 is nothing but 2 followed by 3 zeros, and then we have 2. So if I add all these three numbers, we will get 2,000,000, 2000 and 2. Let's add these numbers. We have 2 followed by 6 zeros. Then we have 2000, that means 2 and 3 zeros afterwards, and we have 2. If I add them, it will be 2,002,002. So this is the number that is equal to 2,002,002 in figures. All right. Now let's solve the second question. Put one pair of brackets into this calculation to make it correct. So we have been given this expression. Right now this expression is incorrect, but we have to insert one pair of brackets in such a way that this expression holds true. So there is only one way to solve this question, that is by hit and trial. Okay, so the only way we can solve this is by hit and trial. Hit and trial means that we have to try out the different combinations of the placement of the brackets. So we can put either 2 or 3 numbers together inside the bracket, do certain operation, and then find out the answer. So when I did that, I found out that when you put a bracket here and here, and then you solve this expression, it will give you 0. Let me show you how. First, you have this 5. We know that we have to calculate the part inside the bracket first. For that, I will multiply this one because the rule of BODMAS says that I need to first do the multiplication. For that, I will have to multiply. 4 into 3 is 12 minus 9 minus 2, right? Let's solve this again. This part, 5 minus 12 minus 9 will give you 3. Then you have minus 2. 5 minus 3 and 2, 5. 5 minus 5, 0. So this expression holds true if I place my brackets like this. Okay, so this is the solution for this question. Now let's move to the question number 3. The expression that is given here, 7x minus 8y minus x and minus y. And we need to simplify this, okay? To simplify this, we need to first pair these terms which contain x together and pair the terms which contain y together. If we do that, we will easily be able to see that 7x, when subtracted 1x from 7x, it will give you 6x, and then 8y minus y will give you 9y. Here, I think we can factor out 3, and if I put 3 outside, we will place a bracket. Then here it will be 2x, and with the negative sign, you can write 3y, okay? So this is the simplified version of this expression, and that is our solution for this question. Now let's move to the fourth question. The base of a cuboid measures 10 centimeter by 7 centimeters. Okay, the volume of the cuboid is 280 centimeter cube. Calculate the height of the cuboid. This is a fairly straightforward question. See, the base of the cuboid is 10 centimeter by 7 centimeters. So here I have drawn a cuboid. You can see the base is 10 centimeters by 7 centimeters. That means the length and the width of the cuboid is already given to you. That because the length and the width is what making the base of the cuboid. Now, the another information given in this question is about the volume. The volume of the cuboid is given as 280 centimeter cube. So the volume of the cuboid is given as length times breadth or width times height, and that value will be equal to 280 from the question. Now we know that the length of this cuboid is 10 centimeters, the breadth or the width of the cuboid is 7 centimeters, the height is unknown, the height is what we need to find. So here if I solve this equation, 10 into 7 will give you 70 into h equals to 280. Here if I apply the rules of algebra, I can separate h, 280 divided by 70, and it will leave you with 4 centimeter height. So the height of the cuboid is 4 centimeter, and this is our answer for this question. Let's solve the next question. In a city, the probability that it will rain today is 0.15. Okay. Find the probability that it will not rain today in this city. Okay. So the probability of rain is given, and we need to find out the probability of uh, the fact that it will not rain today in the city. So these two events, rain and not rain, these are known as the complementary events. So if one event occurs, the other one will not occur. Okay. So the when we add the probabilities of these two events, the complementary events, the sum will be equals to 1. So the probability, we can write that the probability of rain added with probability of no rain, this expression will always give you the answer 1, because these two are complementary events, and when we add up the probabilities of complementary events, the summation of that expression will be always equal to 1. Okay, so it is given that the probability of rain is 0.15 plus probability of no rain. That is what we need to find, right? The summation is equal to 1. From here, very easily I can calculate probability of no rain will be equal to 1 minus 0.15, and it will give me 0.85. So 0.85 is the probability that it will not rain today in the city. Okay. Now let's move to the next question. Factorize completely 4x squared y minus 5xy squared. Okay, so let me write that again. 4x squared y minus 5xy squared. Okay, we need to factorize it. Let's see what are the things that we can factor out from these two terms. Here I have x squared and here I have x. I can factor out x from here. Here I have y and here I have y squared. Again, I can very easily factor out y from here. Now, if I have already put x and y aside, that means here I am left with 4x minus, here I will be left with 5y. I don't think I can simplify it any further. So that means we have already factorized the expression. The answer here is xy into 4x minus 5y. Let's move to the 7th question now. The scale of a map is 1:40,000. Okay. On the map, the distance between two villages is 37 centimeters. Calculate the actual distance between these two villages. Okay. To solve this question, one more thing, our answer should be in kilometers. Okay, this is an important point, that we need to convert whatever answer we will get into kilometers. So the okay, first we have to understand this scale. The scale here is 1 is to 40,000, right? That means 1 centimeter in the map, on the map, will be equivalent to 40,000 centimeters in real life. That is the meaning of this scale. Okay, now let me write that for you. 1 centimeter is equivalent to 40,000 centimeter in real life. Okay, now since we have to convert our answers in kilometer, let me do that right now. I know that 1 kilometer is equal to 1,000 meters, right? And 1 meter is equal to 100 centimeters. That means that 1 kilometer, if you multiply these two numbers, will be equal to 1 followed by 5 zeros centimeters. Or you can write this as 10 to the power 5 centimeters in standard notation. With that in mind, I can convert this 40,000 centimeters into kilometer. How? 1 centimeter will be equivalent to 40,000 divided by this number, 10 to the power 5 centimeters. If I do the division, I will be left with 1 centimeter is equal to 0.4 kilometers. So this is the conversion scale in kilometers. Okay. Now how much distance we have here? We have 37 centimeters, right? To convert 37 centimeter into kilometer, we just need to multiply it 0.4. If you multiply 37 with 0.4, you will get, let me just calculate it. This will be equal to 14.8 kilometers. And that is our answer for this question. Without using a calculator, work out 3 divided by 7 minus 1 divided by 14. Okay, let's solve this. 3 divided by 7 minus 1 divided by 14. The easiest way you can do this, just convert it into a single fraction. Multiply these two numbers and write them here. And then just cross multiply. That means multiply 14 by 3 and 7 by 1. 14 multiplied by 3 will give you 42. The negative sign will be placed here. 7 multiplied by 1 will give you 7. If you subtract 7, in 42 you will get 35. 7 multiplied by 14 will give you 98. If you factor out 7, this will be 5 and this will be 14. So 5 upon 14. So here we have our answer as 5 divided by 14. Okay, so this diagram shows a right angle triangle. Okay, right angle triangle means here this is 90 degrees. Calculate AB. We need to find the length of this side AB. This is the length that we need to find. What are given? This angle is given as 37 degrees. The value of BC is 8 centimeters and we need to calculate AB. Okay, so what we can do here, we know that cos 37 degrees, we can write from this figure that cos 37 degree will be equal to AB divided by BC, right? Because for this angle, this one right here is the perpendicular, this one is the hypotenuse, and this one is the base. Since cos theta is equal to B divided by H, so clearly it will be AB divided by BC. Now, we can either use our calculator to find out the value of cos 37, but if you don't want to use calculator, see, cos 37 degree is approximately equal to 4 divided by 5. You can check it using your calculator. It will be equivalent or approximately equal to 0.8. You can equate this with AB divided by BC. Now, we already know that the value of BC is given as 8 centimeters, right? So we will just put 8 centimeters here and we need to calculate the value of AB. From here I can cross multiply. 5 will be multiplied by AB equal to 4 will be multiplied by 8. This will leave me with 5AB equals to 32. Here I can write AB equals to 32 divided by 5, and that is approximately, not approximately, but since we have already taken a approximate value of cos 37, the value of AB will be 6.4 centimeters, and that is our answer for this question. Now let's move to the next question. Find the gradient of the line joining the points -2, 7. So let's assume that this point is -2, 7 and 3, 1. This point is 3, 1. And we need to find the gradient of this line. So how we can find the gradient of the line? For that, let's assume few things. Let us assume that this one is x1 comma y1 and this one is x2 comma y2. So we can write that x1 is equal to -2, y1 is equal to 7, x2 is equal to 3, and y2 is equal to 1. Now the formula for finding the gradient is m is equal to, where m is the gradient, y2 minus y1 divided by x2 minus x1. So what we need to do, we will just put the values, subtract the y coordinates, y2 minus y1. y1 is 1 minus y2 is 7 divided by x2, x2 is 3 minus x1, x1 is -2. Be careful with these operations, okay? Because here is the part where many students make the mistake of not placing this bracket and they will end up with a wrong answer. So let's subtract this one. 1 minus 7 will give you -6 divided by 3. Minus and minus, two negative signs will give you positive sign, -6 divided by 5. So this is the answer for this particular question. The gradient is -6 divided by 5. Next question. Solve the simultaneous equations. 5t minus 2w equals to 19 and 3t plus 2w equals to 5. How we can solve this? Let's see. See here, the coefficient of w is same. Here it is also 2 and here it is also 2. To solve these equations, let's first name them. Let's call this equation 1 and let's call it equation 2. We can easily add equation 1 and equation 2. If I add these two equations, Let me just write it down. 5t minus 2w equals to 19. And here it is 3t plus 2w equals to 5. And what we are doing? We are adding these two equations, right? So if I add these two equations, let's see what happens. 5t plus 3t, this will give me 8t. And this part will be get cancelled out because minus 2 and plus 2 will give you a 0. Here it will be equal to 19 plus 5 will give you 24. Okay. Now from here I can write 8t is equal to 24. T will be equal to 24 divided by 8 and it will leave you with 3. So I have already calculated the value of t. Now the second variable is w and I will calculate the value of w. For that, now put t equals to 3 in equation 1. You can put this t equals to 3 in either of the equation, but for the sake of solving this question, I am just putting it in equation 1. If you put t equals to 3 in equation 1, you will get 5. In place of t, I will write 3 minus 2w equals to 19. Okay. Let's solve this. 5 multiplied by 3 will give you 15 minus 2w equals to 19. Now here I can write this down as minus 2w equals to 19 minus 15 minus 2w equals to 4, right? So w will be equals to minus 4 divided by 2. That will give me minus 2. Okay. So the value of t is equal to 3 and the value of w is equal to minus 2, and this is the solution for this particular question. Now let's solve the 12th question. The first part is 32 into g raised to the power 16 divided by 16 into g raised to the power 8. See how we can solve this. I can write this as 32 into g raised to the power 16 divided by 16 into g raised to the power 8. Okay. Now if you see carefully, this part will be get cancelled out. Here I will get 2, and now I can write it as 2 into g raised to the power 16 divided by g raised to the power 8. Okay. Now just look carefully this part. Okay. See how we can solve this part. We have g raised to the power 16 divided by g raised to the power 8, right? This is nothing but g raised to the power 16, and I can put a division sign here, and this is g raised to the power 8. Now if you recall the rules of power, whenever we have same base and we are performing the division operation, the base remains the same but the powers are subtracted from each other. So that is the rule, one of the rules that we will study in the surds and indices. So this right here, this part can be written as g 16 minus 8. So this will give me g. If you do this subtraction, 16 minus 8 will give you 8. So instead of writing all this, I can just write 2 into g raised to the power 8. That is 2g raised to the power 8, and that is the answer for this question. Okay. Now let's solve the next question. 625 k raised to the power 8 whole raised to the power 3 by 4. Okay. Let's see we can solve this or not. 625 k raised to the power 8 and whole raised to the power 3 by 4. See what we can do here. This 625, right? This 625 can be written as 5 into 5 into 5 into 5, right? So this one is 5 raised to the power 4. Now I have k to the power 8. Let's see how we can write k to the power 8. K to the power 8 is nothing but k squared whole raised to the power 4. How? See, we have to understand one simple thing here, that whenever we have a raised to the power m whole raised to the power n, we can write that as a raised to the power m into n, right? That's how we can write k raised to the power 8 equals to k square whole raised to the power 4, because this 2 and this 4 will get multiplied and 4 into 2 will give you 8. Now, let's just go back here and write 625 as 5 raised to the power 4, and k raised to the power 8 will be written as k squared whole raised to the power 4, and I have to change this bracket here, and whole raised to the power 3 by 4 is always present. Now, what we can do from here? See, here we have something interesting. Whenever we have something like this, a raised to the power m and b raised to the power m, we can always write it as a into b whole raised to the power m. That is exactly what we will use here. Here we have 5 raised to the power 4 and k square also raised to the power 4. So this is our a and this is our b. What we'll do? We will write 5 into k squared whole raised to the power 4, okay, and then whole raised to the power 3 by 4 is always present. Now again look at this property, this one, a raised to the power m whole raised to the power n is equal to a raised to the power m into n. In the same way, these two powers will get multiplied here, okay? This will be multiplied. What we can do? We will write 5k squared whole raised to the power 4 times 3 by 4. This 4 and 4 will get cancelled out. We will be left with 5k squared whole raised to the power 3. What we can do from here, this power 3 will go with 5 and this will also go with k square. So what we will write? We will write 5 raised to the power 3 into k square raised to the power 3. This will give me 5 raised to the power 3 is 125 and k square raised to the power 3. Again we will use this property and these two will get multiplied. That means k raised to the power 6 and 125 into k raised to the power 6 is our answer for this question. Okay, let's move to the 13th question, the first part. This is a Venn diagram that we have been given here. This is a question from Venn diagram and set theory. So we have to shade the reason A union B not. What it means? It means that we need to find out the area from this Venn diagram that represents either A or not B or both. Okay, so we need A or we need something that is not B or either of them. So let's see how we can shade the reason that is indicated by this one. Okay, let's see. So I have already shaded the area that is required. See clearly here I have shaded the whole area inside A. Okay, so this condition is fulfilled, that I have already shaded the area inside A because we need A. Now we also need everything that is not B. So to indicate everything that is not B, we need to shade the area outside B. So all these areas are outside B, and so we need to shade the region outside B because these parts are not covered in B. So we have A and we have everything that is outside B, and that is why this unions operation, A union not B, will give you this shaded region. Okay. Now let's solve this next question. In this Venn diagram, use set notation. Use set notation to describe the shaded area. So this area is our shaded area, and we need to use the set notations to describe this region. First, let's understand what this shaded area represents. Okay. So shaded area, what is it actually representing? See, this is present only in R. This shaded area is present only in R, not P, not Q. This is not touching P. This is not touching Q. It means that we want what we want, all parts inside R. Okay, this is what we want, all parts inside R, but outside P and Q. Outside P and Q. We want all parts inside R, but it should be outside P and Q. Let's see how we can write this in set notation. We want everything that is inside R. Okay, so let's just write R. Then we need everything that is outside P. We need everything that is outside P. That is why I will write P complement. And we also need everything that is outside Q. So I will write Q complement. And I need their intersection. I need the common part. I need these qualities everywhere. So I will write the intersection sign. So this one here is the required set notation that is describing this shaded region. Okay. Now let's move to the next question. Here, this is a question from geometry. P, Q, R, and T are points on the circle. AB is a tangent to the circle at T. Angle ATP is equal to 50 degrees. Angle PTR is equal to 48 degrees. And PQ equals to QR. Find angle PRT. So this is the first part that we need to solve. We need to find the angle PRT. Let's locate this angle on the figure that has been given. Angle PRT, this one, right? This is the angle PRT. We need to find the value of this angle. Okay, now if you can see here, this is a chord PT. Okay, and if you look closely, this one right here is 50 degrees. Here we can use the tangent chord theorem because this is the chord that is making this angle with this tangent, and the same chord is making another angle on the alternate segment. So the tangent chord theorem says that these two angles will be equal to each other. We are using the tangent chord theorem, and that is why this angle here will be equal to 50 degrees. Okay, so this is the answer for the first part. Now we will solve the second question. In the second part, we need to find the angle QPR. Okay, let's see where angle QPR lies. Okay, this is angle QPR. We need to find this angle. Okay, let's call this x degrees. See, this quadrilateral P, Q, R, and T, this quadrilateral is a cyclic quadrilateral. Okay, from the property of cyclic quadrilaterals, we know that the angles facing opposite to each other when added will give 180 degrees. Okay, so if I add this angle Q with the opposite angle, that is the angle PTR, I should get 180 degrees from the property of the quadrilateral, cyclic quadrilateral. Okay, here the value of angle PTR is already given as 48 degrees. So I can write angle Q plus 48 degrees will be equal to 180 degrees. From here, I can eliminate Q. It will be equal to 180 degrees minus 48 degrees equal to 132 degrees. So we have just found out the value of Q, that is 132 degrees. Okay. Now let's examine closely this triangle PQR. I'm talking about this triangle. See, if I draw this triangle outside, it will look like this. Okay, this is our triangle. This is P, this one is R, and this one is Q. This angle we need to find, this is x degrees, and this one is 132 degrees. In this triangle, there is something special going on. You can see that these two sides are equal. PQ is equal to QR. In a triangle, when two sides are equal to each other, the angles opposite to them will always be equal to each other. So this angle will be equal to x degrees because the sides are equal. So the angles facing each other opposite to the sides will be equal to each other. Hence we can write angle QPR equals to angle QRP, and both of them will be equal to x degrees because we have assumed earlier that angle QPR is x degrees. Now in this triangle, we know that the sum of three angles in a triangle is always equal to 180 degrees. So I can write angle QPR plus angle QRP plus angle PQR is equal to 180 degrees. Let's put the values. Angle QPR is x degrees, angle QRP is again x degrees, and angle PQR is 132 degrees. The sum of all three angles will be equal to 180 degrees. If I solve here, it will be 2x equals to 180 minus 132. From here, x will be equal to 48 divided by 2 will give you 24 degrees. So the value of angle QPR will be equal to 24 degrees, and that is the answer for this question. Let's solve the next question now. The time taken for each of 200 students to complete a calculation is measured. The cumulative frequency diagram shows the results. Use the diagram to find an estimate for part A, the interquartile range. Okay, we need to find the interquartile range. Let's go back to the graph. This is the graph. You can see here we have two axes, the cumulative frequency and the time. Let's call this x the time axis, and the cumulative frequency one, let's call it y. Okay, so you can see that we have 200 students here, right? The total number of the students is 200. To find the interquartile range, let's just calculate 25% of 200. 25% of 200 will be 25 divided by 100 into 200, and it will be 50. And now calculate 75% of 200. 75% of 200 will be equal to, if I factor out 25, this will be 3 divided by 4 into 200. It will give me 150. Okay, so the 25% of 200 is 50, and 75% of 200 is 150. We have to understand that since this is the cumulative frequency axis, this one, the y-axis I'm talking about, we have to find these two values on the y-axis. See where we can find this 50 and 150. Okay, now let's try to locate 50 and 150 on the y-axis. Okay, so here you can see that we have 40 and this one is 60. So I am pretty sure that 50 will lie in the middle of 40 and 60, exactly at the middle of 40 and 60. What will I get? I will get 50. So let me put a dot exactly at the middle of 40 and 60. So this is my 50. Okay, now let's find where 150 is. 150 will be at the middle of 140 and 160. Do you agree with me? So 150 will be exactly at the middle. Here I will put a dot, and this dot is supposed to be 150. Okay, now next step is to draw a horizontal line passing through these points that will meet the graph. I'll show you how. See, I have drawn two horizontal lines. First is passing through 50 and the second one is passing through 150. And both of these lines are meeting the graph. Let's call this point A and this point is B. So at point A and B, these horizontal lines are meeting with my cumulative frequency graph. Okay. The next step is to draw a perpendicular line from these 2 points on the x-axis. I'll show you how we can do it. See, here you can see that I have drawn 2 perpendicular lines, first from the B on the x-axis or the time axis, or here from A to the time axis. Let's call this point B dash and this one A dash. Okay. Now the next part is to find out what these points are. So for that we need to count the boxes here. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 boxes. 10 boxes and the time duration is also 10. So each box is 1 unit worth of time. So let's just count the box 1, 2, 3, 4, 5, 6. So this one is nothing but 6. And if you add 6 in 10, you will get 16. And here also we can start counting 1, 2, 3, 4, 5, 6, 7. So when you add 7 on with 20, you will get 27. So this one right here is what we call the first quartile, the Q1, and this one is the third quartile, Q3. The interquartile range that we need to find, the interquartile range is given by Q3 minus Q1. So you have Q3 as 27, you have Q1 as 16, When you subtract these values, you will get 11. So 11 is our answer for this question. Next part is find the number of students taking more than 40 seconds to complete the calculation. Okay, so let's go back to the graph. This is the graph. Here we have 40, right? We need to find the corresponding value on the cumulative frequency graph. For that, we will draw a perpendicular line passing through 40 and meeting the graph. This is the line. Okay. Now this line is meeting the graph at this point. Let's name this point. Let's call this P. Now to find the corresponding cumulative frequency, I need to find the corresponding Y value on the cumulative frequency axis. For that, what I will do, I will try to draw a line that is passing through P and horizontal, and this is the point that I will get on the cumulative frequency axis. Okay. Now we have to understand one simple thing, that all the students who are above this line, those are the students who have taken more than 40 seconds to complete the calculation. Okay, so we need to find how many students are there in this part. Here the gap between 200 and 180 is 20, right? And there are 5 blocks. You can see 1, 2, 3, 4 and 5 blocks. So we have to understand that these 5 blocks are sharing this 20 students. These 20 students are shared by these 5 blocks. So one block will denote 20 divided by 5, 4 students, right? So this block will share 4, this block will share 4, this one 4, this will also share 4, and this one will also share 4 students, because 4 times 5 will give you 20. Now where are we? We are here, right? This is the point that we need to find. So this block has already given me 4 students. This is also 4, this is also 4. So 4 plus 4 plus 4 will already give you 12. Now this here, this point is at the middle of this block. So there will be 2 students here and 2 students here. So if you add them up, there will be 2, and this 4 will give you 4 plus 2, 6. So there are total 6 students who are above this line and who are taking more than 40 seconds to solve this question. So the total number of students taking more than 40 seconds to solve the question is 6. Okay. Now let's solve the next question now. A is equal to pi r squared plus pi dh. Rearrange the formula to make h the subject. Okay. So we have to understand one simple thing. If h is our subject, h must lie on the left side of the equation. See how we can do this. We have been given a is equal to pi r squared plus pi dh, right? To make h the subject, we need to keep h at the left side. So what I will do, just take this pi dh and bring it to the left side. This will leave me with pi r squared minus a. Okay. If I take the negative common from the both sides, I will get a minus pi r squared with a negative sign here. These negative signs will get cancelled out. Pi dh is equal to a minus pi r squared. From here, I can write h is equal to a minus pi r square upon pi d. So here, in this formula, I have made h as the subject because we are finding the value of h. This is what it means to be the subject in a formula, because we are able to find the value of h using the values of a, r, and d. So this is the answer for this question. Let's solve the next question. 2.1 into 10 raised to the power 1 over 1 multiplied by 8 into 10 raised to the power 1 over 1. Let's see how we can do this. This will be equal to 2.1 into 10 raised to the power 101 into 8 into 10 raised to the power 101. See, if you multiply these two numbers, 2.1 and 8, you will get 16.8 into 10 raised to the power 101 into 10 raised to the power 101. Now, we know that if we have the same base but the different indices, we will just add them up. So you will write 10 raised to the power 101 plus 101. It will give you 16.8 into 10 raised to the power 202. Now, we have to understand one simple thing, that we need to move this decimal here because we need to give our answers in the standard form, right? So for that, I will write 1.68 into 10 raised to the power 202. But since I have moved the decimal towards the left, one place towards the left, I will have to put 10 raised to the power 1 here. And when you calculate this part, you will get 1.68 into 10 raised to the power 203, because the bases are same, so the powers will be added to each other. Okay, so this is our answer for this question. Now let's solve the next question. 2.1 into 10 raised to the power 101 plus 2.1 into 10 raised to the power 100. To solve this question, we need to factor out the smaller power of 10. Okay, so I can factor out 2.1 and the smaller power of 10. The smaller power of 10 is among between 101 and 100. 100 is the smaller power, so I factored it out. It will leave me with 10 here and 1 here. So 10 plus 1, 2.1 into 10 raised to the power 100 into 11. This will give me 23.1 into 10 raised to the power 100. If I want to write it in the standard form, I will have to move this decimal leftward, and 2.31 into 10 raised to the power 100 into 10 raised to the power 1, because I have moved the decimal one place to the left. So 2.31 into 101. So this is our answer for this question. Let's solve the next question. The diagram shows two sides, VA and VB. Let me show you VA and VB, okay, of a regular polygon. AVX is a straight line, angle VBX is y degrees. This one is VBX. This VVX is equal to y degrees, and this AVB, this one is 11.5 y degrees. Okay, so we need to find the number of sides of this polygon. Let's see how we can do this. Okay, First of all, this AVX is a straight line. So, since this is a straight line, I can write all the angles made on it will be equal to 180 degrees. The sum of all the angles will be 180 degrees. So, if I add them up, it will be 12.5 into y degrees will be equal to 180 degrees. Y degree will give me 180 degree divided by 12.5, and if you solve them, this will be equal to 36 0 360 degree divided by 25 degrees. Okay, just multiply by 2. So what you can see here, this angle is 360 degrees divided by 25. Okay, so we know that the exterior angle of a polygon is given by 360 degrees divided by n, where n is the number of sides. This is the formula. Now, the exterior angle, this y, is nothing but the exterior angle of this polygon. So the value of y is 360 degrees divided by 25 equal to 360 degrees divided by n. From here, I can clearly write n is equal to 25. So the number of sides of this polygon is 25. Okay. Let's solve the next question now. Here we have been given a graph, and you can see there are two triangles. The first one is T and W. The first question is, describe fully the single transformation that maps triangle T onto triangle W. So what can we do with triangle T so that it maps completely with triangle W? That is the question. So let's see how we can do this. Okay, let me just draw the outline of triangle T first. Here I have drawn the outline of triangle T. Now, if you can see that if I rotate this triangle 90 degrees clockwise, see, this was my original triangle, right? And triangle T, and I am rotating it clockwise 90 degrees. Okay, this one is full rotation 90 degrees clockwise, and if I take this triangle here, it will completely cover triangle W. So this is the single transformation that we are looking for. We have to clockwise rotate this triangle 90 degrees, and if we do that, this triangle T will become triangle W. So what we need to do, we need to rotate this triangle T 90 degrees clockwise. Okay. The next part is, draw the enlargement of triangle T with scale factor -2 and the center of enlargement is -1, 1. So our scale will be -2 and the center will be, what will be the center? -1, 1. Okay. Let's find out all the sides of this triangle T. This one clearly is 1 units, and this side is 1, 1 and 1, 3 units. Okay. So when we scale it with the factor of 2, this side should become 2 and this side should become 6. Okay, this is what we need to keep in mind. Next, the center of enlargement is -1, 1. So we need to point that minus 1 comma 1. Here I will get minus 1 comma 1. So this is the point of enlargement, minus 1 comma 1. Okay. Now what does this negative sign means? This negative sign means that the enlarged triangle or enlarged shape will be inverted. Okay. So we will be getting an inverted shape. Let's see how we can do this. Okay. First step should be naming all the vertices of this triangle. Let's call this A. This one is B. Okay. And this one is C. Now we will have to join these vertices to this point of enlargement and draw a line. Let's see how can we do this. Okay. Here you can see that I have drawn 3 lines passing through the center of enlargement and each of the vertices of the triangle. Okay. So let's call this, since this line is passing through A, I will call it A dash. This one is passing through C, so this one will be C dash. And this one is passing through B, right? So this one will be B dash. Now we know that the scale of enlargement is -2, so all the sides will be doubled. So this BC will now become B dash C dash and its value should be 2. So 2 units we have to see that where the gap is equal to 2 unit. Here the gap is equal to 2 units, 1 and 1. So this will be one of the sides of the triangle that we are looking for, BC. And then we need to find A dash. So we have already found 2 of the vertices of the enlarged triangle. Now we need to find the third vertex. See, here we can see that A and B is a perpendicular line to BC. So here on the enlarged circle, we will try to draw a perpendicular passing through B. Okay. Let's see how we can do this. I will draw a perpendicular line. Okay. See, let me draw the perpendicular and I will wait till it touches A dash. Okay, here this line is touching A dash. So this will be the third vertex of my triangle. And now I will join the remaining vertices here. This, let's call this P, Q, and R. So this triangle PQR is the inverted with scaling factor 2 and center of enlargement -1, 1. So this triangle PQR is the required triangle that we were asked in the question, the inverted with the scaling factor 2. Okay. You can also check the lengths of the side here. This is 1 plus 1, 2 units. And here if you can see 1, 2, 3, 4, 5, 6. That is exactly double of 3. So this is very accurate and this will be our answer for this question. Let's solve the next question. Here we have been given fx equals to 3 raised to the power x plus 2. We need to find the value of x when fx is equal to 245. Let's solve this question. We have been given fx equals to 245. Okay, this is the value that has been given in the question paper. Now we know that the function fx is equal to 3 raised to the power x plus 2, and that is equal to 245. And in this scenario, we need to find the value of x. We can write this as 3 raised to the power x, 245 minus 2. This is 243, right? 3 raised to the power x equals to 243 can be written as 3 into 3 into 3 into 3 into 3. Okay, so this 3 raised to the power x will be equal to 3 raised to the power 5, and if we compare the powers from here, we can write x is equal to 5, and that is our answer for this question. The next part is we need to find the value of x when f inverse x is equal to 7. Okay, so we know that the value of fx y equals to fx equals to 3 raised to the power x plus 2. Okay, to find the inverse we need to interchange x with y. So earlier our equation was y equals to 3 raised to the power x plus 2, and now to find the inverse we will interchange the x and the y. So it will become x is equal to 3 raised to the power y plus 2. What we did, we just interchanged this x and y with each other. In place of x, I wrote y, and in place of y, I wrote x. From here, you can see that the value of f inverse x is already given as 7. Okay, so this y can be written as 3 into f inverse x plus 2. So here x is equal to 3. The value of f inverse x is 7 plus 2. So this 3 raised to the power 7, you use your calculator and you will get 2187, added with 2 will give you 2189. Okay, so this is our answer for this question, 2189. Let's move to the next question now. Write the recurring decimal 0.41 as a fraction in its simplest form. See, you can see that 1 here, we have this bar or dot symbol. That means this 1 is repeating. So we need to find 0.41 bar as a fraction in its simplest form. Okay, let's see how we can solve this. Let x equals to 0.41 bar. Now we can expand it as 0.4111 dot dot dot, and this will go on. Now since there is only one digit repeating after the decimal, we will multiply this equation both sides by 10 raised to the power 1. Why 1? Because there is only one digit after the decimal that is repeating. Okay, so that is why I have multiplied this equation both sides by 10 raised to the power 1. Let's see what happens. So if you multiply 10 with x, it will give you 10x, and if you multiply 10 with 0.4111, the decimal will shift rightwards one place, so it will give you 4.1111 dot dot dot. Okay, so this is the new equation that we have. Now before moving forward, we need to do some rough work. Okay, let's do it here. This rough work will consist of a subtraction. We need to subtract two numbers. First one is this one, 4.1111. Okay, so we will take this number and write it here, 4.1111 dot dot dot, and this will be our second number. Okay, this is 0.4111 dot dot dot. So we will subtract these two numbers. Let's see how we can do this. All of these will be equal to 0. This will be 7 and this will be 3. Okay, so the value that I am getting is 3.7. Now what we will do, We will write 10x here, and now take this 3.7 and this 0.4111 and add them up. Write 3.7 here plus 0.4111 dot dot dot. If you add these two numbers, okay, if you add these two numbers, you will get 4.111. Why did we write this way? You will see why. See, here we can write 10x, this one is 3.7, and this one, this 0.411. What is this? This is nothing but x. See equation 1. From equation 1 you can see this 0.4111 is nothing but x. So here in place of this number I can just simply write x. Now I can solve this equation. This 10x minus x will give you 3.7. This is 9x, 3.7, and clearly x is 37 divided by 19. So this is the simplest fraction that could be written, and this is our answer. Let's solve the next question now. Tan x plus root 3 is equal to 0 degree for x belongs to 0 degree to 360 degrees. Okay, so here we have been given tan x plus root 3 is equal to 0. We can write tan x equals to minus root 3. We know that tan 60 degree, right? Tan 60 degrees is root 3. So our reference angle for this question is 60 degrees. Okay, but clearly here tan x is negative of root 3. That is negative value. We have to ask this question, where is tan theta negative? Okay, where is tan theta negative? Let's try to find the answer for this question. See, we have 4 quadrants that we learned in trigonometry. In the first quadrant, all the values sine, cos, and tan, all the values are positive, right? In the second quadrant, let me just write the quadrants here. This is the first, second, third quadrant, and this is the fourth quadrant, right? In the second quadrant, only the sine theta is positive. The other trigonometric ratios are negative. In the third quadrant, tan theta is positive, and in the fourth quadrant, cos theta is positive. All other ratios are negative. Okay, so where is tan theta negative? That is the question. Tan theta is negative in second quadrant, right? And tan theta is negative in the fourth quadrant. So our answer in quadrant 2 will be x is equal to, this whole angle is 180 degrees, right? So to find the corresponding angle, we need to subtract our reference angle with 180. This will give me 120 degrees. This is for the second quadrant, and for the fourth quadrant we need to find the angle. Fourth quadrant means we need to subtract this reference angle in 360, so that will give me 300 degrees. Okay, so our answer will be, we will have 2 different angles for which tan theta is negative root 3. First one is 120 degrees and the second one is 300 degrees. Okay, So this is the solution for this question. Let's solve the next question. Here we have been given an expression 2 divided by y plus 1 minus 3 divided by y, and we will have to answer in its simplest form. We will have to convert this into a single fraction. Okay, let's do this. First multiply these two terms, y plus 1 and y. Then we will cross multiply 2 with y and y plus 1 with 3. So it will be 2y with a negative sign here, 3 into y plus 1. Multiplying 3 with y plus 1 will give me 3y minus 3 divided by y plus 1 into y. Okay. If you subtract these two, this will give you negative y minus 3 divided by y plus 1 into y. This is the answer for this question. Okay. Let's solve the next question. Here, the diagram shows a triangular prism with a cross-section triangle, triangle BCV. Angle BCV is 90 degrees, and BC is 5 centimeters, CV is 4 centimeters, AB is 15 centimeters. Calculate the angle between AV and the base ABCD. Okay, let's see how we can solve this. First of all, we will try to locate all these values that are given in the question. First of all, this angle BCV is 90 degrees. Okay, where is BCV? Here. This one is given as 90 degrees. This BC is 5 centimeters. This one is 5 centimeter BC. CV is 4 centimeters here. CV is 4 centimeters. AB is 15 centimeters. And we need to calculate the angle between AV. AV, we need to draw this one first. Okay, let's draw AV. Here I have drawn AV. This is the line AV with the base ABCD. Okay, so this one is the base actually, ABCD. I will draw this ABCD. This is the base, and we need to find the angle with the base. Let's draw a diagonal to this rectangular base ABCD. Let's see how we can do this. This is A and this is C. Okay, I have drawn this diagonal, and we need to find the angle between AB and base ABCD. This is the angle that we need to find. Let me write that here. Angle VAC. We need to calculate the angle VAC. For that, we will need certain lengths. So let's start finding them one by one. At first, let's go to the triangle BCV. Let me draw that here. VCV. This one is B, C, and V. This one BC is 5 centimeters. The length of CV is 4 centimeters. With the use of Pythagorean theorem, we can calculate the length BV. BV will be equal to root under 4 squared plus 5 squared. This will give me root under 41. Okay, so the value of VV is root under 41. We have already covered this triangle. Okay, now let's go to the triangle ABV. A, B, and V. Let me show you where this triangle is in the figure. See, this is A, B, and V. I'm talking about this triangle. This is also a right angle triangle. Here, the length of AB is already given as 15. Okay. The length of BV is given as root under 41 that we have just calculated. Okay. And we need to find the length of AV. Again, we can use the Pythagorean theorem here. AV will be root under root 41 squared plus 15 squared. If you solve this one, it will give you 41 plus 225. Solving it further will give you 266. So this value is root 266. And let's just go to a different triangle now. I'll show you this one. We are targeting triangle VCA. Let's go to the triangle VCA. Let me change the color. VCA, V, C, and A. Okay. In this triangle, we need to find this angle. Okay. This will be our answer. Let's call this theta. Let me draw that triangle here. So this is A, this will be C, and this is V. We need to find this angle. Let's call it theta. This one is root under 226. This is 4. So let's see how we can do this. Okay. In this triangle, if I try to find the value of sine theta will be equal to P divided by H, perpendicular divided by hypotenuse. So P, the value of P is 4 divided by root under 266. From here, I can write theta is equal to sine inverse 4 divided by root under 266. If you use your calculator, this will give you approximately 14.196 degrees. So this is the solution for this question. Let's solve the next question now. We have to simplify this equation. Let's see how we can do this. Okay. See here, if I take P common, I will be left with minus T plus 1. And from here, if I take plus 1 common, I will be left with minus T plus 1. Okay. And here, I have 1 minus T squared. Here, I can write this as minus P 1 minus T plus 1 into 1 minus T. Okay. Divided by 1 minus T squared. I can factor out 1 minus T here. And here I will be left with minus P plus 1 divided by 1 minus T squared. I can write this as 1 squared minus T squared. And here, see, A squared minus B squared is A minus B into A plus B, right? If I use that here, I can write this as 1 minus T into 1 plus T. Okay. And here I have 1 minus T into 1 minus P. These two will get cancelled out and I will be left with 1 minus P divided by 1 plus T, and this is the answer for this question. Let's solve the next question now. In the diagram, O is the origin. OP vector is given as P. Okay, so this is our OP vector. This is given as P, and OQ vector, OQ, this is OQ. OQ vector is given as Q. R is the point of intersection of PQ and OS. Okay. With PR is to RQ is 1 is to 2. Okay. So this is an important part. PR is to RQ is given as 1 is to 2 and OR is equal to RS. Okay. So we need to find the position vector of S. Here we have S, okay, position vector of S in terms of P and Q. And we need to give our answer in its simplest form. This is the question. See, let's see how we can do this. See, we have PR ratio RQ is equal to 1 is to 2. Okay. If you see the diagram closely, you will see PR plus RQ is PQ. Okay, see here, PR plus RQ is nothing but PQ. So from here I can write, if I add these two parts, 1 plus 2 will give me 3. So PR is 1 by 3 of PQ, the total value, and RQ will be, since RQ has two parts out of 3 of PQ. Okay. Now, if I look closely, let's try to realize this vector right here. This one, PQ. Okay. If I try to realize this vector PQ, this is nothing but Q vector minus P vector. Okay. Because from the triangle law of addition of vectors, we know that if I had written QP vector, it could be P vector minus Q vector, but since I have reversed the direction, it will be Q vector minus P vector. Okay. So here, if someone tries to write this PR vector, we know that PR is just 1 by 3 of PQ. Okay, so 1 by 3 of PQ means it will be equal to 1 by 3 Q vector minus P vector. Okay, and if someone is trying to write the RQ vector will be 2 by 3, because RQ is 2 by 3 of PQ. So RQ vector will be 2 by 3 Q vector minus P vector. Okay, now if I go to this triangle OPR. Let's draw this triangle here. This is O, this one is P, and this one is R. Okay, I have this vector as P. This one is 1 by 3 Q vector minus P vector, right? So here in this triangle, this OR vector is nothing but the resultant of all these two vectors. Okay, so I can write that OR vector is OP vector plus PR vector. Okay, so OP vector is nothing but P vector plus PR vector is 1 by 3 Q vector minus P vector. This can be written as P vector plus 1 by 3 Q vector minus 1 by 3 P vector, and if we subtract, we will get 2 by 3 P vector plus 1 by 3 Q vector. Okay, so this is the value of vector OR, right? This is the value of vector OR, but we need to find the position vector of S. So we will have to find this vector OS. Okay, we will need to find this vector OS, but we know that this is the point of intersection. These two parts are equal to each other. That means OR is equal to RS. So that is why we will just need to multiply 2 with OR vector and we will get the OS vector, that is the position vector of S. So 2 times OR vector is 2 by 3 P vector plus 1 by 3 Q vector. If you multiply 2 inside, it will be 4 by 3 P vector plus 2 by 3 Q vector, and this is the answer for this question. That is it for this question paper. If this helped, like and subscribe to support the channel and stay updated with new videos every week. Until next time, stay focused and keep solving.